Hi dear students, welcome back to mathematics online classes. In a previous video, we have taken that what is the function and what is the real valued function and some of the functions of their domain, codomain, range and as well as graph of the function. Two functions are over. What are those? One is identity function, another one is the constant function. Next one is a polynomial function. Next one is a polynomial function. What is meant by polynomial function? I think in the school level, people already know about this one. Now I am just giving the definition of the polynomial function. What is a polynomial function? Is nothing but a function which is of the form. A function which is of the form. I just denote the function f of x is equal to a0 plus a1x plus a2x square plus a3x cube plus son plus an into x power n, where an is not equal to 0 and n is the any positive integer and the a0, a1, a2 a0, a1, a2, so on n are any real numbers. a0, a1, a2, a3, so on n are any real number. Then this function is said to be a polynomial function, or else is called a polynomial function. It is called a polynomial function of the degree n. Polynomial function of the degree n, or nth degree polynomial function. This is the definition of the polynomial function. What is the definition of the polynomial function? A function which is of the form f of x is equal to a0 plus a1x plus a2x square plus so on an into x power n. Here total, how many variables are there? Only one variable is there. What is that variable? X is there. So x square, x cube, x so on x power n. Highest power of the variable. What is the highest power of the variable? Highest power of the variable is n is that. That's why it is called as a nth degree polynomial function. Either you can write in this manner. First of all, you can write the an x power n plus or a1 x power n, a2 x power n minus 1. In that manner also you can write. I just written order. Power of the x in increasing order. In reverse also you can write. Doesn't matter. Either this one or another form you can write. What is the other form? Is nothing but a1 into x power n, a2 into x power n minus 1 or a0. a1 into x power n minus 1 plus a2 into x power n minus 2 plus on an. In this manner also you can write. Is that clear? Okay. Whatever. Either this one or this one. A function which is of the form f of x is equal to a0 plus a1x plus a2x square plus 1 an into x power n. Here condition is that this an should not be equal to 0. What happens if an is equal to 0? If an is equal to 0, then the x power n term will be eliminated. Then this is not a nth degree polynomial function. So that reason an is not equal to 0. Next, this n is a positive integer. Which are the degree? Nth degree. That must be the positive integer. And these a0, a1, a2, a3, so on n. What are these? These are the coefficients. These are all the coefficients. These coefficients are taken as any real number you can take. These coefficients you can take it as any real numbers. So this is called as a polynomial function of the degree n. Best definition. Obviously, it is a polynomial function after placing a1, a2, a3, so on any real number. What is the domain of the function? Domain of the function is set of real number itself, and codomain is also the set of real number. There is nothing change in the domain and the codomain. It is obviously a real function. Real function is nothing but what? Domain as well as codomain are the set of real number or a subset of the real number. So this is the definition of the polynomial function. Particularly, you can take the examples. What are the example? For example, f of x is equal to x square plus 2x plus 5. What is the highest power. What is the highest power of the variable? Variable highest power is 2. Therefore, it is said to be a second order polynomial function. Next, we can write f of x is equal to 3x cube plus 4x square plus 5x plus 7. This is also a polynomial function. What is the highest degree of the polynomial function? 3. Therefore, it is third degree polynomial function. Similarly, f of x is equal to x power 9 plus 7 into x power 6 plus 6 into x cube plus 8. This is a polynomial function. What is the highest power of the variable? Variable highest power is 9. Therefore, it is called as a 9th degree polynomial function. Remaining values are not there. What are the remaining values? Means x power 8 is not there, x power 7 is not there, x power 5 is not there, x power 4, x square, x are not there. Which means that these variables coefficient is 0. This variable coefficient is what? 0 is there. That's why that term is not present in the polynomial function. That's all. Nothing that more than that one. So these are the particular examples. So many examples we can write. Extension part is nothing but now we need to draw the graph of the polynomial function. How to draw the graph of the function? I just take one particular example. Draw the graph of the function. Graph of the real function is given by f of x is equal to x square. Draw the graph of the function f of x is equal to x square and also write the domain and range. Write the domain and range of the function. Domain and range of the function. Here, is it a polynomial function? F of x is equal to x square? Yes, obviously it is a polynomial function. What is the highest power of the variable? 2. Second degree polynomial function. X is not there, constant is not there. That is nothing but their coefficient is 0. Here x is not there. X is not there means x power 0 is there. Obviously, this term we can call it as a constant term. This is the coefficient of x, coefficient of x square, coefficient of x cube, so on, coefficient of x power n in that manner. Anyway, we are required to draw the graph of this one. F of x is equal to x square. Now I am just going to choose the x and y values, corresponding x and y values. If x is 0, what is y value? Y is nothing but f of x. Y is nothing but f of x. If x is 0, what is the f of x value? F of 0. Wherever x is there, replace 0. 0 comma 0. If x is 1, what is the y value? Y value is nothing but f of 1. That is nothing but image of 1 under the function f is how much? Wherever x is there, replace the 1. 1 square value is 1. If x is 2, what is the y value? X value is 2. 2 square is 4. If x value is 3, what is the value? 3 square is 9. If x value is 4, what is the function value? Y value 4 square 16. Is that clear? Suppose if x value is minus 1, because negative real numbers. If x value is minus 1 square is 1. If x value is minus 2, what is the y value? That is plus 4. If x value is minus 3, it is a plus 9. Is that clear? Similarly, if x value is 0.5, if x value is 0.5, what is the square of the 0.5? 0.5 square is 0.25. Are you clear? Similarly, 1.5 square, 10 square, that we can write it 2.25. Is that clear? In that manner, each and every real number has the images. Therefore, it is a function. Now, we need to draw the graph of the function. Okay, anyhow, I just take the graph of the function here. Okay, so I just consider the xy coordinate plane. This is the positive x-axis, negative x-axis, positive y-axis, negative y-axis. On the x-axis, 1, 2, 3, 4, so on. Negative side, -1, -2, -3, -4, so on. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. Negative side, -1, -2. That's enough because negative values are not there. Now, check that. So plot the points. First of all, x comma y, that is nothing but 0 comma 0. 0 comma 0 is nothing but at the origin. Next, 1 comma 1 is that. Where is the 1 comma 1? X value is 1, y value is 1. 1 comma 1 is here. Next, 2 comma 4 is that. 2 is here, 4 is here. 2 comma 4. Next, 3 comma 9. X coordinate 3 and y coordinate 9. 3 comma 9. Can I join these points by a straight line or a curve? Can I join those points by straight line or curve? Here it is a curve because I just taken integer values only. For example, what is the value of 0.5? Image of 0.5. 0.5 is here. What is the image of 0.5? If x is 0.5, what is the y value? Y value is 0.25. 0.25 is nothing but 1/4 of this value. That is nothing but here is the point. Next, 1.5. 1.5 is here. Next, it is a 2.25. 2 is here. 2.25. 2.25. Like that. Each and every real number has the value. Each and every real number of x has the particular images. Therefore, the graph is like this. This is how it extends on the positive side. Now come for the negative side. Negative side, minus 1 is the x value is minus 1, y value is plus 1, minus 1 comma 1. X value is minus 2, what is the y value? Plus 4, minus 2 comma 4, minus 3 comma 9, like that. Similarly, minus 0.5 comma plus 0.25, minus 0.25 comma plus 0.25, like that. So here also all the values is that. This is the graph of the function f of x is equal to x square. It is the graph of the function f of x is equal to x square. Okay, now we are required to write the domain of the function and the range of the function. What is the domain of this function and what is the range of the function? Domain means x values. What are the x values you are choosing? You are choosing x values as all the real numbers. Yes, obviously. The domain of the function is set of all the real numbers. Domain of the function is set of all the real numbers. Next, range of the function. What are the range? What are the y values? Y value is the required range. Observe that 0, more than 0 only is there. On seeing this one, more than 0. Or else, come to here. If you come to graph, observe that y value. Y values are taking including the 0 and more than 0. More than 0 means positive real number only you are considering. Are you sure about this one? Y value. Y value are observing that 0 and more than zeros are there. So that 0 including all the positive real number. Positive real number including the 0. Positive real number including the 0. 0 is not considered as a positive or negative real number, so that positive real number except the 0 and union of singleton set 0. This is the set representation because these are the sets are there. Positive real number 0 is not included. Included 0 of union. Union means all the elements of this set, all the elements of this set. Singleton set 0. It is not an empty set. It is a singleton set. In this set, there is an element 0 is there. So this is the domain, this is the range, this is the graph of the function f of x is equal to x square. In this case, if they ask the question polynomial function, how they will ask the question is, so define a polynomial function and draw the graph of the function f of x is equal to x square or else f of x is equal to x cube. Either this one or this one they used to ask f of x is equal to x square, write the domain and range of the function, or draw the graph of the function f of x is equal to x cube and write the domain and range of the function. This is already explained. Now, draw the graph of the function f of x is equal to x cube. Pause the video, just draw the graph of the function f of x is equal to x cube. Yes, draw the graph of the function f of x is equal to x cube and write the domain and range of the function. Sometimes they used to for all x belong to the R, for all the real number. Same manner, I just consider that let f y is equal to f of x, or else keep as it is and is equal to x cube. Either you can write y is equal to x cube or write the f of x is equal to x cube. Now get the x and y values. X and y values. If x is 0, what is the y value or f of x value? Wherever x is there, replace 0. It is 0. If x is 1, what is the 1 cube is 1. If x is 2, 1 cube, 2 cube is 8. If x is 3, 3 cube is 27. Like that it continues. Similarly, negative values. If x is minus 1, minus 1 cube is minus 1. If x is minus 2, minus 2 cube is minus 8. If x is minus 3 cube is minus 27. Like that. Similarly, if x is 0.5, if x is 0.5, what is 0.5 whole cube? 0.5 cube is 125. That is nothing but here it is 1 cube. 0.125. 0.5 whole cube is 0.125. Like that. 1.5 cube, 2.5 cube. For example, we can take all the values. That is not necessary anyhow. Anyway, now draw these values in the graph. Consider the xy coordinate plane. Y-axis. This is the x-axis. 0, negative side of the x-axis. On the x-axis 1, 2, 3, 4, 5, so on up to infinity. Minus 1, minus 2, minus 3, minus 4, so on, minus 5, so on, negative infinity. Here 1, 2, 3, 4, 5, 6, 7, 8, so on up to infinity. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, so on up to negative infinity. Now plot the points 0, 0. Where is that? At the origin. 0, 0 is that. 1, 1 is that. 1, 1. This is the 1, 1. Next 2, 8. 2, 8. Directly comes a 2, 8. Next 3, 27. 3, 27. 3, 27. Next 4, 64. 4, 64. Because 4 cube 64 is that like that. Now, what about the values? Smaller values are there. What are the smaller values? 0.5. 0.5 value cube is 0.125. Very closer to the x-axis. Here is the point is that. Like that. So, each and every real number has the images. Therefore, the graph of the function is like this. Graph of the function is goes like this. Next, these are the positive values. Now come for the negative values. What are the negative values? Minus 1, minus 1, minus 1, minus 1. Here is that. Minus 2, minus 8. Minus 2, minus 8 comes directly downwards. Similarly, here smaller values has the images, therefore it continues in this manner. Okay, this is the graph of the function f of x is equal to x cube. This is the graph of the function f of x is equal to x cube. Now, our interest is to write that domain and range of the function. What is the domain of the function and what is the range of the function? Domain means always remember that x value. What are the x values you are choosing? All the real numbers you are chosen. Therefore, domain of the function is set of all the real numbers. Range. What is the range we are getting? After replacing x value, what is the y value you are getting? Y value means what are the y value you are considering? All the real numbers have you considered? Yes, therefore the range of the function is set of all the real numbers. Domain and the range are set of real numbers. Each and every point has the images and the pre-images are there. So this is the domain, range, graph of the function f of x is equal to x cube, definition, polynomial function. Instead of after asking the polynomial function, they might have asked to draw the graph of the f of x is equal to x cube or f of x is equal to x square. Is that clear? So here very careful. Domain is same, real number, but range is different for x square and the x cube. Very carefully, you have to write the examination. Okay. Now this is the all about the polynomial function definition and examples of the polynomial function. Now the next thing is next function, that is fourth function is rational function. Fourth function is rational function. Rational function. What is meant by rational function? To discuss the rational function, first of all we should have two polynomial functions. Let g of x and h of x, g of x and h of x are any polynomial functions. Polynomial functions. Here, to discuss the rational function, I just consider the two functions. What are the two functions? Polynomial function. Let g of x and h of x are the any two polynomial functions. Then f of x is said to be a rational function, which is of the form g of x divided by h of x, provided that h of x is not equal to 0. Provided that h of x is equal to h of x is not equal to 0. As you know that rational number, what is a rational number? A number which is of the form a by b, provided b is not equal to 0, or number which is of the form p by q, provided that q is not equal to 0. Either this one or this one, none of the same. In the same manner, rational number definition is that same functions are there. Here, people have taken that a and b are the any two real numbers. Here, instead of numbers, functions are there. G of x and h of x are the any two functions. Particularly, those are the polynomial function. What is the polynomial function? I already know that g and h of x are any two polynomial function. Then f of x is the rational function, provided that g of x divided by h of x, whenever h of x is not equal to 0, is called a rational function. Is called a rational function. What is the rational function? Rational function is nothing but g of x divided by h of x, or f of x divided by g of x, provided given two functions are polynomial function. This is the definition of the polynomial function. Obviously, these two are the polynomial function means g is having r into r, and as well as h is also from r into r. That is nothing but domain, and the codomain of g function and h function has a set of real numbers or subset of the real numbers. Okay. Definition is clear. Now let's move to the example. What is the example? Now I just consider the one example for rational function, that is draw the graph of the function. Draw the graph of the function. Draw the graph of the function. F of x is equal to 1 divided by x. Draw the graph of the function. F of x is equal to 1 by x, where x is not equal to 0. And also write the domain and range. And also write the domain and range of the function. And also write the domain and range of the function. Okay. Previously also written several three functions graph you are written. Same manner here also we need to write. And one thing they are given. Usually they used to give. For example, if they given identity function f of x is equal to x, they used to give for all x belong to the real number r. Constant function f of x is equal to c, for all x belong to the r, they used to give. But here f of x is equal to 1 by x, where x is not equal to 0. What happens if you take an x as 0? If you take an x as 0, 1 divided by 0. What is the 1 divided by 0? 1 divided by 0 is not defined. 1 divided by 0 is not defined. Suppose 0 by 1, yes, 0 by 1 is 0, but 1 by 0 is not defined. Here, not defined. What is that? Any number. Any number divided by 0 is not defined, and 0 divided by any number. 0 divided by any number is equal to 0. Some people used to say that any number, anything divided by 0. Don't say like that. This is not anything. This is any number divided by 0 or 0 divided by any number. Okay, remember both are important. Just mention at the first page of your notes or last page of your notes. Anyway. So here 0 is not included because of we are getting a not defined. In that reason, they have not taken a 0. Except the 0 bit, what is the real number? Real number 0 ಬಿಟ್ಟು ಎಲ್ಲಾನು ಅಂದಾಗ all the real number s after 0 ಬಿಟ್ಟು 0.1 is included, 0.01 is included, 0.00000001 is included, but not exactly 0. Approximately this is a 0, but not exactly 0. These values are included, but not a 0. S after 0 are the real numbers. Now we need to draw the graph so that consider the x and y values. If x is 0, can I take the x is 0? Which is not possible. X is not possible to take the 0. What is the domain of this function? Means real number s after single times at 0. Reach what will get? Check it. Obviously, set of real number or subset of the real number. Here we get of the real number as a product. 0 is not possible, so that x value is 1. What is the f of x value? F of x value is 1, or y value is 1. If x value is 2, what is the f of x value? 1 divided by 2. If x value is 3, what is the f of x value? 1 by 3. If x value is 10, what is the f of x? 1 divided by 10. If x value is 100, what is the value? 1 by 100. Exactly. On taking the as increasing the x value, y value is decreasing. Suppose if I take 1 by 10 as x value is 1 by 10. In that case, what is the y value? 10. Is that clear? If I take 1 by 2 as x value, in this case it becomes a. Are you sure? Now, instead of taking the negative value, I just directly move to the graph of the function. Later you can take the negative values. This is x-axis, negative side of the x-axis, y-axis, negative side of the y-axis. Here 0, 1, 2, 3, 4, 5 so on up to infinity, minus 1, minus 2, minus 3, minus 4, minus 5 so on up to negative infinity. And here 1, 2, 3, 4, 5. Here minus 1, minus 2, minus 3 so on up to negative infinity. Now plot the points. 0 is not possible. 1, 1. There is that 1, 1. 1, 1 is here. Next 2, 1 by 2. 2 is here. Y value is 1 by 2. 1 by 2 is nothing but 0.5. 0.5. 2, 0.5. Next 3, 1 by 3. What is the 1 by 3 value? 1 by 3 value 0. How much? 1 by 3. 1 by 3 value is 0.3333 will carry 0.33. Where it is 3, 0.33. Here it is 0.5. 0.33. Here it is 10 is that 10 very close, or 4 will just take 1 by 4. What is the 1 by 4? 0.2, very closer to the x-axis. On increasing the x value, y value is decreases. If you take 100 means x value is 100. 1 by 100. 1 by 100. This 1 centimeter value divide into 100 part. Out of the 100 part, only 1 point. Very closer to the x-axis. Are you sure? Next, 1 by 10. 1 by 10 is the x value. What is the 1 by 10? 1 by 10 is the x value. Very closer to the 0. 1 by 10. What is the y value? 10. 1 by 10. 10. Very here. Next, for example, 1 by 2 is that. 1 by 2 is nothing but here. X value is 1 by 2. What is the y value? Y value is 1 by 2, 2. Here it comes. On decreasing the x value, if it comes taken x value from here, y value is increases. Is that clear? So that it is very closer to the x-axis and closer to the y-axis. It is closer to the x-axis. If you extend increasing the x value, it is closer to the x-axis. If you decreasing the x value, it is closer to the y-axis. And it never touches the x-axis and never touches the y-axis. If x value increase ಮಾಡ್ಕೋತೇವೆ, ಇದು ಕರ್ವ್ ಬಂದು x-axis ಅನ್ನು ಟಚ್ ಮಾಡೋದೇ ಇಲ್ಲ. It never touches the x-axis. If you decrease the x value closer to the 0, it never touches the y-axis. These are all about the positive value. Come for the negative value. Negative value means I just change the sign of the x values here. Minus, 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 minus all. If it chosen these are all minus, obviously these values are also minus value. That is nothing but minus. X value is minus, y value is minus. Same curve is carries. That means I just write directly This is the graph. It is decreasing the x value closer to the x axis and increasing the x value. ikkade modaga increase agutavo increase ಮಾಡ್ಕೋತ 0 negative ಇಂದ 0 ಕಡೆ ಹೋದಾಗ closer to the y axis. Is closer to the y axis but never touches the y axis, never touches the x axis. This is the graph of the function f of x is equal to x. Now domain and range. What is the domain of the function and what is the range of the function? What is the domain? Domain. Here positive values, negative values. All the values is taken. 0.1 is just taken. 0.001 is taken. 0.000000001 is just taken, but not exactly 0. Therefore, domain is all the real number s of the 0. 0 bit with the large value domain. Is that clear? Next, what is the range? Range is range or 0 vartada? No, it will not answer 0 in the range because as you approaches to the 0, it never gets the value. Therefore, range of the function is set of all the real number s of the 0. Set of all the real number s of the 0. There is a possibility is that to becomes a 0. So in the continue along 0 for the possibility is there, but will not include that one. Anyhow, I can write this one. This is the domain and this is the range of the function. This is the domain and the range of the function of the rational function. Rational function is clear. G and h are the polynomial functions. Then f is said to be a rational function if g of x is divided by h of x, provided that h of x is not equal to 0. Here, further, I just already explained that f of x is a rational function. This is the polynomial function. This is a polynomial function. That means if you compare here, g of x is equal to what? 1. H of x is equal to what? X. Whether these two functions are polynomial functions, whether these two functions g of x is equal to 1, h of x is equal to x, whether these are a polynomial function? Yes, obviously these are the polynomial function. What is the degree of this polynomial function? Degree of this polynomial function is 0. Degree of this polynomial function is 1. Why? Because 1 is there means can I write as 1 into x power 0? Highest power of the variable is 0. Therefore, 0th degree polynomial function. What is the highest power of the variable? 1. First degree polynomial function. Obviously, these are the polynomial function. Then, can we say that identity function and constant function are also a polynomial function? Identity function is nothing but f of x is equal to x, h of x is equal to x. Constant function is nothing but f of x is equal to c, g of x is equal to 1. C value is 1. So identity function and constant function are also called as a or identity function and constant function are the particular examples for the polynomial function. These are the particular example for the polynomial function. These are the particular example for polynomial function. Is that clear? Very simple. Okay, domain and the range, very important thing. Now, in the same manner, we can continue the remaining 3 functions in the next video. Okay, thank you.